Okay, can everybody hear me in the back as well? Louder? Louder, okay. So this is going to be a short history of ipv4, so I'm not going to keep you here for the full hour probably. For full disclosure, I work for the RIPE NCC. We are the regional internet registry for Europe, the Middle East and Asia. That doesn't mean that you can interrupt the talk if you have problems with any of your address space requests. If you do, come and talk to me after the talk and bring lots of liquor. So, why are we having this talk? The red line is the total global available unallocated ipv4 address space. As you've seen, that ran out a while ago. The green line is the bits that are still left at the 5 regional internet registries, and that's going to run out very soon. So, where does all this come from? In the beginning, before there was an internet, there were other networks. There was the telephone network, there was the postal network, etc. These networks were, the telephone network anyway, it was a very centralized system. All the capacity, everything had to be planned carefully, and it was circuit switched, meaning every time you want to do something on the network, it would build a circuit from the source to the destination, and every switch along the way would have state. Every switch along the way would know about your connection. So then things like the Cold War roll along, and in the 60s computers started appearing, and even these very old computers were already much more useful if they were interconnected or if people could interact with them from a distance. So there was some early research into computer networks, but they all ran over that circuit-switched telephone network. Eventually, even the army noticed computers were useful, and they were, of course, very worried about the Russians and of nuclear attack. So what would happen to this centralized telephone network if a bunch of nuclear weapons dropped on the United States? Well, the network would die if a few of the central nodes would disappear. So a guy called Paul Barron, who worked for the RAND Corporation, got the contract to do some research into networks that would survive a significant number of nodes being taken out. So he did some research and published a few papers in the early 60s, first one in 1961, where he basically describes decentralized networks that don't keep any state inside the core of the network. Went on to invent packet switching in the same paper, which is when every routing node along the network will then individually take a decision where to route the packet without actually knowing the entire topology of the network, like in a telephone network. And you can see in the picture here, he did actually get a medal from the other big genius that we had in the last century. Now, Paul Barron, he was a very smart guy. There's some really nice things you can find in his old papers, especially things like, therefore, we would like to consider the interconnection one day of many all-digital links to provide a resource optimized for the handling of data for many potential intermittent users, a new common user system, which is what the internet that we have today is. A little bit further, you find the time division multiplexing, which is what the telephone system used, appears so natural to data transmission that we might wish to consider an alternative approach, a standardized message packet format. And then in that same paper, he comes up with this, which is not so different from the IP header that we see today. He was actually, he was a smart guy. And a few years later, he writes some more papers about what this might mean for society and how it is probably unwise to be storing lots of data about everybody everywhere and then give people like law enforcement access to all that data, which is a theme that we still see today at conferences like this. Then another guy shows up, Licklider. He worked for BBN, and he in 1968, basically publishes one paper where he describes Jabber, Facebook, Wikipedia, Amazon, and something he called Oliver, which would be this all-knowing helper on the internet, on the network, which would know everything about you. It would know who your friends are, it would know who you communicate with, it would know where you would like to shop and the things you would like to see. So basically he described Google as well, all in 1968. As a result of this, this research, the DARPA, part of the US Department of Defense, contracted BBN to actually build a network so they could do some more research and have some experience with this. So on October 29, 1969, the first message ever was sent on the ARPANET. Low. The GIN followed a few hours later after they recovered from the router crash, which happened at this point. So. Now, the early ARPANET did not run on TCP/IP yet. It ran on something called NCP, the Network Control Protocol. And a host, a computer on the network would not actually take part in the network protocols. There'd be a router, an IMP, there would be a router there that would actually do all the networking, and the host would be connected to that router via a serial link. So then Vint Cerf and Robert Kahn show up, and well, actually a lot of other people as well, but they were the main drivers behind it, to develop this NCP into something better. And they come up with TCP/IP, basically the same TCP/IP that we still use today. And I had a lot of fun digging in all the old papers and meeting notes and that kind of thing. Because in a meeting in 1977, Vint Cerf already proposes that it's maybe time to develop a new protocol and replace FTP. Now I counted them. There's 69 public FTP servers on this network here. So I guess hackers are just very conservative by nature. Then finally, in 1983, they shut down the entire internet and upgraded to TCP/IP. And that's, I think, the day the real internet like we have today was really born. So finally, TCP/IP is deployed. Now, before we get to today, there was one last hurdle that this new packet-switched open technology had to take, and people who were involved with the internet in the 90s know it as the protocol wars. Because, of course, there were a few other people besides all these hackers in Berkeley and who thought networking was a good idea as well. People involved with the telephone industry, for example. So they came up with the OSI protocol stack. Who knows about the OSI protocols here? Oh, quite a few people. Good. Good, good, good. Now, I think of all the pieces of all the papers and things I went through, this is the most telling, which is an argument for using OSI and not using TCP/IP. It says, for one, TCP/IP is getting a little long in the tooth. The essential services and mechanisms found in all 5 of the TCP/IP protocols have not changed for at least 15 years. This was a strong argument against TCP/IP in 1988. I think Vint Cerf and Robert Kahn did a pretty good job because this thing they came up with in the 70s is still working today. Now, I'll skip through this very quickly because most of the people in this room will know about this. RFC 791 describes 3 classes of network. Class A networks, very, very large, have 16 million addresses. Class B networks have 65,000 addresses. And Class C networks, they're really small ones with 256 nodes in them. Now, this probably looked fine in 1983 when the ARPANET, the internet, was very small with a few hundred connected nodes. If you dig in some older RFCs, you actually find a version of this where there is only one class of networks. So there are 256 possible networks. At some point, apparently, someone thought that that was going to be enough for this new global network. But very quickly, 791 came along because someone thought it might actually grow a little bit bigger than that. So in 1993, it was clear this classful addressing was not going to work, and they came up with classless interdomain routing, because the problem was mostly that they were running out of Class B space, because there was a lot of Class C networks, but there were many networks that were a little bit larger than 256 nodes, but not quite, 65,000 nodes. So they were running out of Class B space, and the Class A's were running out pretty rapidly as well. By that time, they had, I think, only 11 Class A's left. So they come up, RFC 1519, which defines classless interdomain routing, which we still use today. And it basically says that there's not the host and network division in the IP address is not on a byte boundary, but it can be on any bit boundary. So you get your /30 on a point-to-point connection. And we're still using that today. And this helped a lot in making sure that we didn't run out of ipv4 addresses already in 1993. So how does this address space distribution on the internet work? In 1972, even before long before TCP/IP was deployed, they had socket numbers for the different services that ran on the NCP protocol that the ARPANET used at the time. And of course, lots of people were using different socket numbers, and you had collisions, and it was all very, very annoying. So this guy, John Postel, he said, okay, everybody send to me the socket numbers you want to use, and I'll keep track of the list of them. And that's basically the birth of the IANA, the Internet Assigned Numbers Authority, and up to 1998, he was the IANA. Now, by 1998, after he died, of course, ICANN was already there, and ICANN thought that they would be perfectly positioned to take over the function of the IANA, and they did. Also, during these years, it was realized that as the internet got bigger and bigger and bigger, this one guy with a beard sitting in the United States was maybe not the right setup for handing out addresses to these thousands and thousands of organizations that needed addresses. So already a long time before the ICANN took over, regional registries were started. The RIPE NCC was the first in 1992. APNIC and ARIN followed quickly after that. APNIC for the Asia-Pacific region and ARIN for the North American region. And then in 2000, LACNIC. Up until the creation of AFRINIC, Africa was split between ARIN and the RIPE NCC. And only this year, we have finally cleaned up all the last bits of transferring everything to AFRINIC that was needed when they were created. And these 5 organizations have basically been handing out IPv4 address space in their regions since then, since their creation. And the IANA hasn't been handing out addresses directly to organizations, although if you look at all the RFCs that define how this system is supposed to work, the option is still there to go to the IANA. But I think the IANA, if you try, the IANA will actually send you to one of the RARs. The only exception is global multicast addresses. So if you need any global multicast addresses, you can still get them from the IANA. So what is the current status of all this? On February 7 this year, all 5 RARs got the last /8 block from the IANA. All IANA has left right now are a few bits and pieces, tiny pieces, for example, with the leftovers from the global unicast space, things like that. And that was, for us, for the RARs, the last address space we will ever receive from the IANA. APNIC is going through quite a rapid growth, or at least they were going through quite rapid growth until April 15. That's when their rapid growth suddenly stopped, because that's when they allocated the last address space from their public pool. The next one to go is probably us here in Europe, and It's difficult to say when that's going to be because if you look at how the distribution is of allocation sizes, you see that most of the address space goes to very few, very large allocations for very large DSL providers and organizations like that. And if all of them come in 1 month, then we run out a little bit quicker. But somewhere in the next 12 months, if you come to us and you ask for IPv4 address space, we are going to tell you no. Of course, this is not news. It's been known for a while that IPv4 is going to run out one day. In 1998, IPv6 RFC was published. And even a little bit before that RFC was published, we allocated our first IPv6 block. 1998, we didn't know we would quite make it to 2011 with IPv4, but we figured we'd have about a decade or so. And that should have been enough time to deploy IPv6 everywhere, right? I want to see a show of hands. Who has IPv6 connectivity at home? Now, if it's tunneled, put your hand down. I see one hand. OK, so that's the state. Oh, two hands. So that's the state of IPv6 deployment today. Now, if you live in the RIPE NCC service region, you have less than 12 months, is my estimate, to get it sorted out. Now, if you look at the camp network here, I think on the wired network there is IPv6, but on the wireless there is no IPv6. I've been told that is because the latest software upgrade for the wireless equipment that Cisco came out with broke IPv6 connectivity. So the future is probably going to have NAT, lots of NAT, double NAT, triple NAT. I think next camp we should maybe try that, put the same /24 network in every room or in every tent or every bunker, and just NAT it all together and see how well that's going to work. Now the other thing, all the congresses and the camps, they always had, for the last many years, 81.162 or 81.163. This is going to be the last camp with that address space, because by the time the next camp comes along, it's all going to be gone. So yeah, if even Cisco on their wireless software, wireless equipment can't support IPv6 properly, then deploying v6 is going to be difficult. So you may want to start looking into all the different transition technologies and that there are out there, and maybe experiment a little bit, like what if I have my server behind 2 NATs and then my client behind 3 NATs? How am I going to make this work? Because you could probably make a lot of money consulting in the next few years. So, like I said, it was a lot of fun reading up on all these old papers and old meeting notes and all these things. And if you ever have a few hours or a few days or a few weeks to spare, I think I can recommend doing it, because you're going to find a lot of fun things, and you're going to get a nice idea about how all this came to be, this whole internet, because it's all very clear to us. Packet switching, IP addresses, no state in the core. It's all very natural to us because we don't know any better. But 40 years ago, it all didn't exist. It was all new. So I said it'd be a short history of IPv4. If there's any questions, I'll be happy to take them, but use the microphone so the people watching the streams hear it as well.
Hi, a internet address policy lurker, you could call it. Oh, hey.
Hi.
So I'm sort of a internet address policy lurker,
okay,
so to speak. And I wonder if, in your private opinion, you think the current hierarchical organization of internet node addressing is resilient against various forms of abuse when entities are able to revoke delegations by merely removing a line in a database.
By what, sorry?
By merely removing a line in a database.
You mean the whole IANA RAR LAR system?
Yes.
And what do you mean by removing something from the database exactly?
Well, the RIPE has a database of...
We have the WHOIS database that lists, okay, just for the audience, we have a public WHOIS database. Anytime we make an address assignment or allocation, we put it in that database so everybody can look up who has which addresses. So what do you mean exactly by just removing a line there?
Yeah, by removing an entry for some network.
But not everybody can remove that line.
No, but RIPE can.
Yes, we can. Yeah, we can. It's our database, of course, so we can remove that. We're not really supposed to. There are processes in place that we can do it, and we have done it. In every single case where we've done it, it has been a situation where someone has opened an LAR in the name of non-existent companies and things like that, which is, you know, clear fraud, signing fraudulent contracts. And in all of these cases, also the organizations involved were not your ordinary ISPs. So it's not, but it's not something we've done a lot. It's happened a few times, maybe a handful of times. And even then, if we remove a line from the WHOIS database, that is not going to shut down the network, because we're not the routing police. We just have a book, and in that book we write your name behind these numbers, and then if we, you know, cross out that line, that's not going to change anybody's router configuration. So even though, yeah, we, you know, own that database and we could do it, it's going to be very public when we do. We have processes in place that, at least so far, we have always followed, and it's not going to have an immediate effect on the routing on the internet anyway. So even though it seems there's a lot of authority centralized in one place, I think the risks are fairly small. Does that answer your question?
Yeah, I have a follow-up question.
That's okay.
Do you think this may change?
Ooh, that's a tricky question. There have been a lot of voices telling us to be more proactive with taking away people's address space, because some people, you know, don't like getting spam or things like that. And we've always had the position that we are not the internet police. We just keep track of who's using what numbers, and that's all. So there are currently no mechanisms or processes in place that say anything about what you can do with your addresses. So if you send us a request, you say, I need some addresses because I'm going to send lots of, you know, penis enlargement spam, we are happy to give you the addresses. If you show us, you have that number of servers. So, you know, we don't really care what you use them for, and we don't think we're in the position to have to care what you would be using them for. Now, for a while ago already, a few years ago, of course, law enforcement found out about us. And they came to us, of course, and they go, hey, we have these guys here, can you take them off the internet, please? And it was actually, you know, you think you can explain how it works and then they'll go away, but no, we had to actually make a lot of efforts to make them explain to them that yes, we could remove that from the database, but it is not going to make them stop sending this spam. In fact, the only thing that it's going to do is to make them send spam from unregistered address space, so you have really no idea what kind of, you know, where it came from. And right now the situation is there that the law enforcement still comes to us quite a lot, but mostly asking for information. And in every case so far, we point them to the WHOIS database. Sometimes we have to hold their hands in, you know, getting them to query the WHOIS database. But that's the current situation. So it's because, you know, to get to your question, we don't have an effect. We can't pull somebody off the internet. We just can't do it because we don't control all the routers. So I think the risk also in the future is pretty small.
Even if the routing security thing?
That's a whole different kettle of fish, yes. Some background for the rest of the audience. The BGP protocol that handles all the routing between networks on the internet is also a pretty old protocol, so it has basically no security features. If you're connected somewhere on the internet, you have a BGP router, and you start advertising a prefix, then pretty much the rest of the internet will think that you have these IP addresses and start sending you packets. And there is there's been some protocols published, and I think there's 1 or 2 implementations as well of actually securing this by, in different ways, signing all the route advertisements with public key cryptography, so that if you receive a route from your ISP that says that 5 hops further up there is a guy that has some address space, that you can actually verify if this is the case. Of course, the root of these kind of systems needs a root, a trust anchor, and the natural trust anchor for this kind of thing is the guys that hand out the addresses, because they know who they give the addresses to, and that would be us. And as a first step in maybe one day deploying this, that day is, I think, pretty far away, because it's not a simple thing to deploy, and it's a little bit late now to have a flag day like FinServ had in 1983 to just turn off the internet and then bring it back up again. So I think the day that this actually gets deployed, if it ever happens, is far away. But as a first step of that, we have begun issuing X509 certificates, certifying that whoever has the private key to that certificate is the legitimate user of these addresses. And because everything the RIPE NCC does in terms of addressing is governed by our address policies, and they are not written by us, they are written by the address policy community that has a lot of lurkers, and also some active people, but it's open to anyone. If any of you guys think, I like to tell Alex what to do, get on the address policy mailing list and start taking part in the discussions. And there's been a big discussion there, because of course, once you have routing security, and you have concentrated the issuing of the certificates somewhere, all of a sudden that somewhere does have some power to influence routing. There's been a big discussion there in the address policy community, and I don't think that discussion is over yet. I think there's going to be a lot more discussion, and I really have no idea where it's going to end up. So.
There are 2 questions from IRC.
Okay.
Aren't you going to keep some address spaces for, let's say, a short-term project like the camp or Progress?
Yes. While I was here at the camp, I got the message that a policy proposal in the address policy working group to set some address space aside for temporary assignments is going to be accepted. So we are going to keep some address space apart for temporary assignments, such as a bunch of guys camping out in the field. But unfortunately for the guys at the NOC, that policy is probably going to be a little bit more restrictive than the policies we've been using so far, so they may not get a /16 the next time. But there will be at least some address space. At least 1 IP per visitor.
And there is another question. The question is, isn't anything being done reclaiming old Class A networks that are not in use anymore?
Yes and no. A few Class A's have been returned, some because they were not in use, some because they were not a little bit in use, and the people who used them were good internet citizens, and they renumbered to some other address space and gave them back. The rest of them is actually in use. You may not see them routed on the internet because they're behind nets, but the rest is actually in use. And they may not be used efficiently. Quite a few of them are used very sparsely, meaning there's a /24 here with 2 hosts and a /24 there with 2 hosts. But in the end, it's still a very big network, and renumbering that would be fairly costly. And the organizations who hold these Class A's are not very keen on doing this. People have asked, why don't we take them back? By just deleting the line from the database. And of course, we looked into that as well. But there's quite a few legal issues associated with them because we are not the ones who gave them those /8s. So it's going to be difficult for us to say we're taking it back because we didn't give it to them. And at the time they were given this space, there was no requirement for them to use it efficiently. So legally, this would be a fairly difficult situation, and we had a bunch of lawyers look at it, and they were not sure that we could ever win this from people like IBM and Apple and HP and people like that. And then the final reason why we decided to not really pursue this is that it's not going to solve anything. Because if you look at the run rates over the last few years, getting a bunch of these Class A's back would give us, what, 6 months of extra space? And that's not really going to help anybody.
The guy is very active. He has another question.
Okay.
What is your position on trading and selling IP addresses?
My personal position is that it's unavoidable. The RIPE NCC's position is also that it's unavoidable, and we, therefore, if you can't beat them, join them. So we're going to actually actively support this as well. I'm not sure if it's going to happen a lot, because if you look at who really needs a lot of address space in this world, it's the big ISPs that have millions and millions of DSL and cable clients. They need a lot of address space. And then if you're on the other side, you start looking at, so who has address space that they could sell? You see that most of the address space is with these exact same guys. So you'd be in the situation where the guys needing the address space would be the guys selling the address space. So that's, I think, not going to work. So I personally expect we're going to see some trading of smallish blocks. Maybe occasionally there'll be some large block transferred, but you see some trading of smaller blocks. But in the end, if Deutsche Telekom can't get any v4 address space anymore, it's not going to be worth their while to start getting little bits of pieces from address space from all different people. They're going to just need a lot of addresses in one go. So the only real solution for them is either deploy carrier-grade NAT or deploy IPv6. And once you have all the eyeballs on IPv6, all the content will follow, and then I think that market will slowly disappear. Yeah. He's been waiting for a long time.
What is your opinion on IPv6 adoption and NAT usage? Do you think NAT is here to stay? And could you imagine an internet where, as a regular consumer, you would only get NAT access and would have to pay more for an actual routable address for incoming connections? Because I think it's already a big problem for things like voice over IP connections. It's fairly difficult to circumvent all the different types of NAT. Do you think that is going to continue?
I think in IPv4, NAT is here to stay. I think most people have some kind of NAT at home anyway, because your DSL router tends to do NAT. So NAT is everywhere, and there's no IPv4 to give everybody, every iPhone and every laptop in your house, a public IP. So in v4, NAT is here to stay. In v6, I don't think we'll see a lot of NAT. But first, of course, we'll have to deploy IPv6. Until then, we're going to have NAT at home, and probably for a period, at least a period, also carrier-grade NAT at the ISP, and maybe multiple layers of NAT there. So I think for the foreseeable future, your NAT is here to stay. And I think you started off by asking my opinion about the deployment of IPv6, and it is way too slow.
But could you actually imagine providers charging for real IP access to the internet?
Happens already today, so I don't have to imagine it.
In your presentation, you had a note about rapid deployment of IPv6 and a nice comment
yes.
behind it.
Yeah,
Could you elaborate that?
Yeah, well, that was mostly referring to the IPv6 on the wireless here. But you see it a lot, that equipment which which, in the specifications it says it supports IPv6, but still today it then turns out that IPv6 is not switched in hardware, but it's done in software. So yes, you can ping through it, but no, there is no feature parity. You see a lot of things like that still today. And you can deploy IPv6 if you plan it right and do it right, but for a lot of networks, especially in places like Eastern Europe, where they don't have so much money to throw around, it's going to be very hard.
Well, I saw an RSC from a French provider which did basically encapsulation of IPv6 in its backbone. What do you think of that solution to get home users to IPv6?
I think you're going to see a lot of solutions like that, and if it works for you, go for it. Because I think it's important to just get it deployed, and then if you have to do it a little bit in a dirty way to get it deployed, good for you. So.
Especially since we started seeing a lot of information in the media about IP addresses running out in the last 6 months to a year, have you at RIPE seen any increase in the amount of interest from large telcos, ISPs, in dealing with this, or has there been any change?
What do you mean dealing with?
Migration paths to either
Yes.
NAT or
Yeah.
IPv6?
Yes, we saw, for example, a huge spike in IPv6 requests when the IANA ran out this year, and another spike in IPv6 requests when APNIC ran out. And over the last year, we have seen a lot more activity, especially from the larger ISPs in talking to us about their deployment plans and things like that. So yeah, there is a lot more awareness, but it would have been nice if this happened 5 or 10 years ago, because now everybody has to really hurry.
One more question.
Mm-hmm.
So the question is RIPE going to push more IPv6?
Sorry, I can't hear you.
Is the registry going to push more IPv6 to ISPs and large corporations in order to improve the deployment?
I think we're pushing it already almost as much as we can, except, short of threatening to shut them down if they don't request v6. But it's very easy to request, and at the moment it doesn't cost you any extra if you request it from us. So I think we're already pushing it. We're doing IPv6 training courses, IPv6 awareness events. We're doing a lot there already. And I'm sure if somebody comes to our external relations team with a good idea, we'll do that as well. So yeah, we're pushing it as much, I think, is reasonably possible.
I live in a country where there is no IPv6 at all, except for the university. And since the internet provider doesn't provide IPv6, the hardware modem they provide aren't IPv6 compatible. So I tried to look after a public modem for the end users to use IPv6, and what I just noticed is that nearly all the routers or modem doesn't support IPv6 right now. There is just a few models, and they are really hard to find.
Yeah,
Why is that like that?
Why that is? That is because some techie at some company says to his boss, I need to deploy this IPv6 stuff because we're running out of ipv4 addresses, and his boss says, why do you need to do that? How is this going to impact our bottom line for our next quarterly reports? And he goes, well, no, the depletion is a few years ago. And he says, okay, then you can't have your new toys. So nobody wanted the toys, so nobody made the toys. And then only fairly recently did, I think AVM was the first one with the Fritzbox, seriously start working on this and come out with a residential DSL router that does IPv6. And now, like you said, there's a few others, but still not so many. But if you live in a country and your ISPs are not thinking of IPv6, I see a business opportunity for you. Any other questions, comments? Then I guess we're done.